All right, in today's video, we're demonstrating finding a solution of a system of linear inequalities. Solutions of linear inequalities are displayed graphically, so we need to graph both of these inequalities. We'll graph this first one in red, and then we will come back and we'll graph this one in green. Our first one there in red is not in a slope-intercept form. We could probably get it into a slope-intercept form. We could also try to just pick some values and put them in. Maybe we'll demonstrate that this time. So for the red one, I'm going to pick some possible inputs and see what I get as outputs for that one, just so we can see where it is that the line goes. So I'll try several here to try to get something clean. I'm a little nervous about the 3 that's in there. So I'm going to try -2, -1. I'll try 0, 1, and 2. And hopefully somewhere along there I will pick up a couple of nice points along the way. So if I put a -2 in for x in the first equation, I would get -2 minus 3y. And since I'm trying to find the boundary line, I'm just going to compare that to -11 here right now. So I would add 2 to both sides. I'm going to show some work here that I will delete later. So -3 is equal to, if I add 2 to both sides, -3 is equal to -9. So y would be equal to +3. I'm kind of get that work out of the way now because I'm in a fairly crowded space. But the point -2, 3 then is on the graph. That's this point right there, so I'll mark that. If I put a -1 in, I get -1 minus 3y. Try to get that to be -11. If I add 1 to both sides, I'd get -3y is -10. And so y would be 10/3. Remember that, 10/3. And put that right in here. That one's a little bit harder to graph. 3 1/3. -1, 3 1/3 is around there. If I put a 0 in, that one's a little bit easier. -3y and -11. But that means y is going to be 11/3. Get that back in there. I guess I didn't need the y equals on there. Just clean that up. And get 11/3 on there, which would be up 1 more third from where it was. That's 3 2/3. I think I see a pattern in the 1 should get me another clean answer. So that's a 1 minus 3y equals -11. So subtracting 1 from both sides, I get -3y is equal to -12, or y is equal to 4. So when I put a 1 in, I get a 4 out. And so I'm happy with that. Now I have 2 numbers. I know exactly where they are. So the next part of the process is then to look and notice that my inequality had an or equal to part. So that should be a solid line that's going through those points. So we'll see if we can make that solid line happen here. I'm going to have to change the properties or the order on this line and bring that out to the front. And we'll see if we can get that to go through all of the points that we want it to. I'll start it here, and then we will stretch it out. It goes out this direction, and it's a little bit easier if you actually have a ruler on a piece of paper, but that's where that line should go. But this was an inequality, so that's just the border, and I have to decide, now that I've figured out where that border is, which side of that line should I be shading on. So I'll do that in the same way that I used to do that with this graphing inequalities, and that's to pick a test point. I will test with the point 0, 0 because it's not on the line. And if I put that into my first equation here, I get that 0 minus 0 is greater than or equal to negative 11. And the question is 0 bigger than negative 11? Then the answer is yes, absolutely it is. So that should be shaded below that equation. All right, so shading below that equation so that I cover up my test point. I'm going to grab the highlighter here to shade with, and I don't have a red option so much in that. Maybe I do. I'll grab a reddish color highlighter and shade below. Okay, we get the idea of where that's shading. And then we need to do the green equation. So our green one is in slope-intercept form. We have a y-intercept at 7 and a slope of negative 2. So I go down 2 and over 1 and down 2 and over 1, down 2 and to the right 1. Get all of those points that this should be going through. And this one is a less than. So on the less than only means that I should have a dotted line. And so if I start connecting my points, let me try to bring that back to the front again. If I connect my points, then it ends up looking something like that. Deciding which side again to shade on, I'll test with 0, 0 again. If I test with 0, 0 again, I get that 0 is less than 7, which is also true. So 0, 0 should get shaded here as well. And technically what that means is that I'm shading this side, and this is going to get a little bit messy as we go through this. There are ways that we can deal with that, but it does give us a pretty good picture of where the answer is, because the answer is in the spot that is shaded dark. Okay, so this region that's kind of bounded by the line here and the dotted line down here, the dark shaded area is where my answers are. Now, I could have done that a little bit differently. I'm going to erase this here, and if I were working definitely with a pen, heaven forbid, then I would probably make some indication that this was supposed to be shaded this way, and then when I found my other one, that the green one is supposed to be shaded this way, and I could already see where my overlaps are going to be, so I wouldn't necessarily need to put anything up there, and I could just come back in and say, well, what's going to be shaded by both of them is this part down here. I can see that by where my shading indicator lines are and what it is that that should look like. Okay? And that is how you graph or solve a system of linear inequalities.